So let's take a look at this problem now. So if you think of the idea of this tan inverse, remember what we plug into a tan inverse is a ratio, which is here, and the output is an angle measure. So I'm going to call this alpha, and then this cosine inverse of 5/13, we're going to call that beta. So that's going to be the initial idea of what we're dealing with when we're dealing with these inverse functions. Now keep in mind when we talk about tan inverse of 4/3, that simply means that we're dealing with a positive ratio. So when we think of inverse for tangent, that's either in the fourth or first quadrant. But since tangent is positive, it's going to put it in the first quadrant, because remember, all students take calc. And what we know is tangent inverse, tangent of theta would be opposite over adjacent. So I'm going to write a 4 here and a 3 down here, kind of corresponding to the ratio 4/3. And then the hypotenuse, once we do the Pythagorean theorem, we'll realize it's 5. And we're going to call this alpha. Okay, now we're going to talk about the next one here. So the next one here, the beta, it's cosine inverse, and that's 5/13, and that's also positive. So that's going to be in the first quadrant, because we're either in the first quadrant or the second quadrant for the inverse. So now cosine of theta would be equal to adjacent. So this 5 up here is actually going to be our adjacent side, and that's over 13. Okay, so then using Pythagorean theorem, this here is going to be 12. Okay, so the angle measures actually do not matter here, because I'm just going to go with the formula for this. Let's just take a look at what that means, because really we're looking at the cosine of alpha plus beta. Okay, so that's really what we're looking at here. So this is equal to, and I'm just going to write it out, cosine of alpha plus beta. And all I'm going to do is fill in what that formula does. So I'm going to look up top here, and we can see that it's this one here. So all we're going to do is write that in. So cosine of alpha times cosine of beta minus sine of alpha sine of beta. Okay, and then all we're going to do is plug in those values from these two triangles we set up previously. So now if we're talking about the cosine of alpha, cosine is adjacent over hypotenuse. All right, so we're just going to plug that in. So that's going to be, 3/5. And then cosine of beta is going to be 5/13 minus the sine of alpha. Now we're going back to that first one. It was going to be 4/5. And the sine of beta is going to be 12/13 because the sine is opposite over hypotenuse. So now all we're going to do here is just kind of multiply the tops and the bottoms and add them together. And we're going to get 15 over 60 for the first one minus 48 over 60 for the second one. And since we have the same denominator here, we can just add these. And that's going to be what? Let's see. 15 minus 48, that's going to be negative 33 over 60, which simplifies to, because 3 goes into both of those, negative 11 over 20. So there's our exact answer that we were looking for this one. So now we're going to verify this identity. So the first step is I'm going to write everything in terms of sines and cosines for all of these pieces here. Because remember, with identities, we start from one side, and using algebra, substitution, and identities, you make it look like the other side. So that's what we're going to do. And we're going to start with the right side here because it looks more complicated. So if you take a look, what I did was I actually turned everything into sines and cosines. And cotangent of alpha is going to be cosine of alpha over sine of alpha, and so on and so forth. And I went through every one of these and set it up that way. Now what I'm going to do is I'm going to have to add these together, so the tops, or subtract them. So I'm going to put a 1 under here. And in order to add those together, I need like denominators. Now, when we're multiplying here, that means I'm going to just multiply straight across. So I'm not going to worry about that here. I'm just going to kind of put it in there. So again, for this side here, let me take that away, I'm going to have to multiply the top and the bottom by the sine of alpha, sine of beta. Sine of alpha, sine of beta for the second one, for 1. And that one I'm just going to keep as it is. This one here I'm going to keep as it is. Okay, so now what I'm going to do for the bottom here, this one here is going to need a sine of beta. So I times the top by the sine of beta. And then this one's going to have to be multiplied by the sine of alpha. So I multiply the top by the sine of alpha. And I'm just going to run through that and show you what that looks like in a second. Now, as you can see, I just consolidated everything together here, and I wrote it just below. So now this actually equals, I'm just going to actually subtract the top now and the bottom here. They won't really subtract, but I'll just kind of write everything together. And you'll see what that looks like now. So here is actually consolidating a little bit more even. So I just simply wrote the subtraction here and then wrote it up top and then over the same denominator. So that's what you're seeing there. So now what we're going to do is we're just going to actually think about this in terms of division here. And when I divide, assuming this is my divide here, as I take the top times the flip of the bottom. So we're going to flip that and multiply. And that's what you're going to see next. Okay, so here we go. Now this is the setup that I was talking about previously. Essentially, we just flip this and multiply it. And that's how we deal with fractions. So what's going to happen here is, you notice these cancel out. And now take a look what we end up with. And then what we do is we just multiply straight across. When those cancel, they leave a 1 in its place. So we end up with this below here. So now take a look at this and the identities above. So now when I take this here, if I look at cosine of alpha times cosine of beta minus sine of alpha sine of beta, that's this identity. Oops, excuse me. That's this, I did it again. That's this, oh shoot. Try it again. That's this identity here. So now what that means for us is we can say that top actually equals cosine of alpha plus beta. And then on the bottom, if you look at that one, that's the sine of alpha cos of beta minus the other one here. Oops, pause.